All right, Algebra Squad, here we go. This lesson is called Graphing Inequalities in Two Variables. So right here on this page, I'm going to just talk about briefly about the difference between the one variable versus two variables. So when we worked with one variable, that is pretty much saying one dimension. So if you look here at this one, you see that we have one variable in this inequality. When we solve it, we can just put it in a number line and then X number line, right? From left to right. Now, here, the ones that we're going to are going to be two variables. We're going to have the variable Y and the variable X. So think of two dimensions. We are now able to move left and right, or graph left and right, and also up and down. So that means we can actually work with the entire coordinate plane, as you see with this example inequality here. All right. So let's get started and let's go ahead and talk about the new things. Question number 1. Graph an inequality with an open half plane. All right, so keyword here is going to be open, and we'll talk about what that means in a second. So our first step here, very first step here, is we want to grab our given inequality and turn it into our graphable form, right? The graphable form, we always like to put it into y equals mx plus b. That's called slope-intercept form. That is because we are able to grab this right here is the slope, right? Slope. And that right there is going to be our y-intercept. We can graph that very easily. All right, so let's go ahead and do that. Y-intercept form is where we get y and isolate it, meaning we put it, we take everything that is not y to the other side, starting with the 3x. 3x is a positive number, so that means that we're going to subtract it to both sides, so we can eliminate it from the left and take it to the right. Let's go ahead and write everything else that did not change. And now, since I want to make this as close as possible as the formula that I wrote down on the right side, I'm going to go ahead and write the negative 3x first, and then I'll write that positive 8 after. All right. Next, what follows here? Well, you need to understand that negative 2 is multiplying with your variable. Anytime that you have a number and a variable next to each other, that implies multiplication. So what I need to do, the inverse operation of multiplication, is to divide. Whatever you do to one side, you have to do it to every single part on the other side. All right, so let's do that. Anything divided by itself turns into a 1. So we're going to get 1y here. We divided by a negative number, so be careful. Warning, make sure you flip your sign. And then we have our sign flipped right here. We have, okay, so this is a little maneuver that a lot of students freak out about. It's something very simple. It requires no type of computation or math here. The first idea is we have a negative numerator and a negative denominator. That means the fraction is actually positive. A negative divided by a negative is a positive. So we can just actually write it as 3/2. No need to simplify this fraction. 3/2 is good enough. We want to see it as a fraction because it's rise over run. That's going to help us with the slope. Next, we can then apply the x variable next to the entire fraction instead of keeping it in the numerator as it is up here. All right, we're going to apply next to it. And then lastly, 8 divided by -2, that's going to give me -4. Done. So here I have slope. All right, that's slope m, and this is b, my y-intercept. So you always start with your y-intercept. You always start with your y-intercept. So right here we have a y-intercept of -4. So we're going to go 1, 2, 3, 4 is located right here. And then I go ahead and create my ladder with my slope, right? My steepness of the line, 3/2. So I'm going to go up 1, 2, 3, and then to the right 2. The reason why I go up 3 and to the right 2 is because you can see that I'm creating a positive sloped line. Okay, this line is positively sloped. If you look at it from left to right, it's going up. I have more room to create more points, so I want to do that so I can get my line a little bit more accurate. 1, 2, 3 to the right 2. And then I no longer have room to go up 3 and to the right 2. So this is good enough. This is where I can go ahead and draw my line. Okay. There we go. Make sure we got arrows on both sides. Okay. Okay, now, I hope, I should have told you this before, But I hope that you didn't create the line. Don't create the line. If you're listening to me right now and you're trying to make this line right now, don't create it. The reason is because we now have to, so step number 2 was graph points using the slope and the y-intercept, which is b. Okay, using slope and y-intercept. Step number 3 is create the line, but you need to understand, you need to see if your line is going to be a solid line. So let's talk about whether it's going to be a solid line, like a regular old line, like the one that I did, or is it going to be dashed? Okay. This kind of looks dotted. Whatever, dotted, dashed, call it whatever you want. Now, what determines if a line is dotted or dashed? Well, that is going to be what type of inequality symbol we have. Just like the inequalities that determine whether it's an open circle or a closed circle, that's the same thing that's going to determine whether it's a dashed line or a dotted line. So if you remember from solving one variable inequalities, the symbols that dealt with or equal to, these are the closed circle or the solid circles, right? Now, whenever we dealt with greater than or less than, that is when we had the open, or, you know, the circle that had space inside. That's going to match up with the line that has space inside or in between, right? So that means if we look back at this original problem and we look at the inequality that we're, well, not really the original, it doesn't matter. The inequality that we have, that right there tells us that we must do a dashed line. All right, so this has to be a dashed line, dotted line, whatever you want to call it. So I can very easily do this. Okay. All right. We are almost done here. I now created my boundary. Imagine that we just created a fence, a boundary. Okay. My solutions are located on one side of this fence. It's either above the fence or under the fence. So it's now time to determine where my solutions are located. So for right now, for space purposes, I'm going to go ahead and erase this. And what we need to do right now is we're going to have to find a point. We have to find a point or look for a point that is going to represent one of the sides. Do we want to talk about a point that's above the line or a point that's under the line? It doesn't matter. Pick one, any of them. So I always like dealing with the number 0, 0 or the point 0, 0 because it's pretty much the easiest, right, to do math. So I'm going to go ahead and test this point out right here, which would be our next step. Test. The testing will tell you where you need to shade. Now, I will tell you right now that there is a little cheat code that you don't have to do the testing, but I am going to do the testing right now just so you are aware and you can practice that. All right, so I am going to be testing the point 0, 0. The point 0, 0, I am going to be putting it inside of my original initial inequality. Or you could put it into the slope intercept form one. That's fine. Doesn't matter. I always like using the original just in case I made a mistake at the beginning. All right. So what do you got here? You got 3 times 0 is 0. 2 times 0 is 0. And again, and this is what you pretty much have. Is 0 a number that's less than 8? Yes, that's true. That's a true statement. So what does this mean? What does this tell us? Why did we care about this? Well, that means that 0 is representing all the points, all of them, that are above this line. And that gave me a true statement. Since I got a true statement, that means that our solutions, and remember, the solutions is plural. Our solutions are located everywhere above the dotted line, okay? So go ahead and create some light shading. Let me make sure I dim down my shading. There we go, so it's not so crazy. All right, so my solution set lies everywhere above that shading. Okay. Let's go ahead and do the little dot idea. If this dot was located anywhere here, if I were to grab the point the x comma y of this green dot anywhere in here, and I were to put it back into my original inequality like I did right now, they will all be true, all of them. Okay, we will always generate a number which is going to be less than 8. Now, if, fun fact, if we look for a point that is on this dotted line, we can use this point right here, which we already got, this point and this point. If we were to do the test with those points and we solve and solve and solve, we are going to get 8 is less than 8. Is that true? Is 8 less than 8? That's not true. 8 is equal to 8. So because of our symbol, that would be a false statement. That is why we have to make this line dotted, because 8 is not equal to 8. And we have to talk about what the symbol here wants us to do, which means that number is not included, or the numbers on the line are not included. All right. Now, just like always, I'm going to go ahead and bring up Desmos here. And let's see what we get. Original equation, 3x minus 2y is equal to, no, not equal to, is less than 8. And here we have it. We have the the y-intercept right here at 0, -4. And we have the shade dotted line here, right? Dashed line. And we have the shading above. Very simple idea. That is done. All right, moving on. Okay. Study tip, determining the inequality symbol. If the shaded region is before the boundary, this was going to be the little a little cheat code that I was going to give you guys. Here's a cheat code. Let's go back here. Come on. Okay, I need to go back to where I can see my my equation. Okay, here it is. Okay, what I want you guys to focus on is my slope intercept form equation. Here is the cheat code. Are you guys ready? As soon as you put your inequality in slope intercept form, just put your focus here. Keep your focus right here. Not really pay attention to anything here. What it says right here is going to guide you to shade. Okay, look what it says. Y is greater than means above, right? So you go to your line and you shade above. Now remember that this line is supposed to be dotted. I just went back too far and it put it solid again. So that's pretty much it. That is kind of, if you want to go ahead and read this again, pause it right now, test it out. And then it is also going to give you the tip on what happens when you have let's say that your line is a vertical line. Where do you shade? Well, when it says greater than, just like it said in the previous one, y is greater than, we will shade to the right because that's where my values are greater. And if it says less than, we would shade to the left because that's where my x numbers are lesser in value. Okay, so we'll put it to practice right now and I'll tell you exactly where it's at. So don't worry about it. All right, so I'm not going to go over the steps anymore. I'm not going to write them down. Let's just go ahead and get right through it, Just remember that we're dealing with a closed half plane. That's what it's called for some reason. I don't know. It's weird. That seems like a new idea. I don't remember using that back when I initially learned this. So we take 3x to the other side by subtraction property of inequality, keeping everything the same. 0 doesn't really do anything, but it actually does. So what I'm going to do is I'm going to write 0 like in blue right here, like it's a ghost, because it's not doesn't do much, but you'll see in a second why I want to keep it. We take 4 to the other side by division. Obviously, we also want to do it to the 0, even though it didn't really matter. We divided by 4. The symbol doesn't flip because we didn't divide by a negative number. We then talk about that this right here is our slope. Apply the variable right next to it, and 0 divided by any number in the world stays at 0. Now, why did I want to bring the 0 along? Why didn't I just not write it? Well, because remember, This right here is still your slope, and this right here is still your y-intercept. Okay, so if it wasn't there, you need to understand, if that 0 wasn't there, you need to use your brain and go, oh, that's supposed, this, since there's nothing, that means my y-intercept is at 0. So how do we graph this? Same exact way. First thing we want to do to graph, we go to our y-intercept, which is at 0. And then we go ahead and do our ladder of -3, 4. This ladder, if you want to go up 3, that's great. Let's go up 3, 1, 2, 3, and then I would have to go to the left. 1, 2, 3, 4. I would have to go to the left 4. But if I wanted to go from here, from the origin and down, 1, 2, 3, I would have to go to the right. 1, 2, 3, 4. Cool. There I go. All right. Before I make my line this time, I'm going to go ahead and look at my symbol and say, okay, that is supposed to be a solid line. Solid. All right. Now, this means that any number that is on this line, any number that falls on the line is going to be part of my solution. In comparison to the other one, the first question we did, the values or the points that landed on the line, on the dashed line, were not part of our solution. All right, so let's go ahead and talk about the little cheat code I told you guys. How do we know where to shade? We know it's a solid line. We know we graphed the line correctly. Our math seems right. Where do we shade? Well, focus on what it says right here. Y is less than or equal to. So just think about less than. Less than is under. So let's just go ahead and shade under. That's pretty much the trick. There is not much to it. But remember, you do want to make sure that you are already in slope-intercept form. So you need to make sure, you know, to make sure that your sign didn't flip or anything like that. The next idea would be, we can actually still test a point just to make sure that we are good to go. And this time I'm going to go ahead and test a point 1, 1, another easy point, right? I'm going to go ahead and test this point right here. So 1, 1. My original equation is 3x plus 4y less than or equal to the number 0. The x and the y that I'm working with right now is 1 and 1. 3 times 1 is 3. 4 times 1 is 4. When I add that together, I get 7. So is this true? Is the number 7 less than or equal to 0? And that is not true. This is false. And it's good. It should be false because the point that I'm looking at right now, the point that I'm testing is located right here. And it's not in the shaded region. It should be false. It should give me a false statement for my inequality. Like I said, my answers are only the dots that are, or the points that are on this line that make this line, and anything else that's below. All right. There we go. One more thing I wanted to do for this one, just to kind of show you what's going to happen, is I'm going to show you, because I already said it for the previous question, but I didn't do one, but I'm going to do it for this one. Let's go ahead and grab this point right here, which is on the line. This point is on the line. And this point is located at 1, 2, 3, 4. It's at -4, 1, 2, 3. It's at -4, 3. So what happens if we put -4 and 3 here? This 3 times -4 is going to give you -12. And then 3 times +4 here is going to give me +12. This is exactly what I told you was going to happen. When you find a point on the line and you plug in the x and the y value of whatever point you want, it doesn't matter which one you use, and you plug it into your inequality, you will get both sides of your inequality identical numbers. Right now, it happens to be 0 and 0. Question number 1, it was the number 8. So is this a true statement? Is the number 0 greater than 0? No. But is it equal to? Yes. True statement. Awesome. There you go. So that's the idea of like being on the fence that I told you. A point on the line will generate the same identical number. So that is kind of like what I like to call on the fence. All right. Come on over here, Graph. Don't be shy. All right. I do encourage you to pause this right now and try it on your own. Let's go. All right. So for this one, we would have to take 2x to the other side by subtraction. What happens here is the 2x cancels, leaving us with y symbol less than negative 2x minus 4. A lot of the time students are like, what do I do now? Why can't I take another number out? I want to divide. You guys are so used to having a coefficient in front of the y, like a 2, and then we would divide by 2. We don't have one, so that's it. You're done. We're all set. This right here is your slope, which is a negative 2. If you want to see it as a fraction, put a 1 under it, so you can see it as rise over run. This is your y-intercept. That's going to be our start for graphing this. So we start at negative 4, and then we use our ladder negative 2, 1. Remember that it's negative, so if I decide to go up 2, I would need to go to the left 1. Up 2, left 1, up 2, left 1, up 2, left 1. Okay? My line right now, seeing my symbol, has to be dashed. Dashed means that any value, any point that is on this line will not make the inequality true, meaning it's not part of my solution. Okay? Okay, there we go. My OCD. No. There we go. Okay, I made my line. And now I determine where my shading is located. My shading is located. Go ahead and look at your slope intercept form. Just the first few parts here. Y is less than. Okay, less than the line means under the line, or in this case, to the left of it. Okay, and there we have it. A good idea, a good practice would be to choose any point on the graph and test out to see if the shaded part is indeed the part that makes it true, and so on and so forth. All right, let's go ahead and see part B over here, where we would start by taking x to the other side. So minus x to the other side. Now remember that if you freak out because there's no coefficient or number in front of that variable, always think that in front of any variable, if it's not given to you, the number 1 is going to be always your friendly neighbor. All right, so now we got negative 2y, same symbol, greater than, minus 1x, sorry, negative 1x minus 4. Here I will go ahead and divide negative 2 to both sides, reminding me that since I'm dividing by negative 2, I must flip my sign. Don't forget to flip out. All right, so flipping my sign gives me y is less than. Remember, here we go. A negative divided by a negative is a positive. So it's 1/2. Put your variable next to it. Again, positive. 4 divided by 2 is 2. Done. Where do I start? I start at my y-intercept. Y-intercept is located at 2. Here it is. Then my ladder is 1 over 2. So I can go up 1 to the right 2, up 1 to the right 2. I have no more space here, so I can go down to the left 2, down to the left 2. Done. This line is also dashed, which means, once again, the numbers that are, the points that are on the line, that make up the line, are not part of my solution. They are my fence, meaning everything to the other side of them will be my solution. All right, so now I talk about what side is my solution, above or under? Go back to your last piece here. Y is less than. Once again, we're shading under. So my solution is going to be everything that's under this dotted line. Anything and everything. It doesn't matter how crazy those numbers seem. As long as it's located in that shaded region, it will make this inequality true. Bam. All right. So hopefully you understood it. If you didn't, rewind it, pause it, ask me. Peace out.